question of CSIR-NET. Actually, this question from functional analysis, and we have given that t x to y be a bounded linear operator. Here keyword is bounded linear operator, and such that both x and y are Banach spaces. That is, both are non-linear spaces plus having completeness property. Now, here t is a bounded linear operator. This implies that there exists c greater than 0 such that norm of t of x less than equals to c norm of x for every x belongs to x. Now, for norm of x equals to 1, this implies that norm of t of x less than equals to c for every x belongs to x, and norm of x equals to 1. And this further implies that this is equals to norm of tx where c greater than 0. Now for this question we use some results. Result first: bisective bounded linear operator T from one Banach space to another Banach space has bounded inverse that we have branched, and results 2 is that kernel of t prime equals to 0 if and only if range of t, that is image of t, is dense in Y, where t prime is a dual map of t. And result 3, final result: if infimum of x not equals to 0, norm of t of x, norm of x greater than 0, and kernel of t prime equals to 0, implies that t is bijective. Now, from given options, actually in a question we have question, which of the following conditions implies that t has a bounded inverse? Now, using these 3 results and the question statement, we notice that from option D, for option T, that is infimum of norm of x is equals to 1 and norm of t of x greater than 0, and t of x is dense in Y. Now we simply added this. As norm of x is equals to 1, this implies that x cannot be equals to 0, and norm of t of x same, and we just add here norm of x in a denominator greater than or equal to sign as it is, and t of x is dense in y. Now using results 2, infimum of x not equals to 0, norm of dx upon norm of x greater than 0, and from results 2 we have t of x is dense in y if and only if kernel of t prime is equals to 0 using 2. Now using result 3, this implies that t is bisective, and using result first, this implies that bisective bounded linear operator t from a Banach space to another Banach space has bounded inverse, that is t has bounded inverse. This implies that option D only is correct here, because this is a part B question, that is option D is correct, and option C is a half of condition, and option B is also incorrect, and option A is also incorrect. So